Okay, so in part one of the video, we looked at the double integral side of Stokes' theorem, and we showed it was 75, where my f function's up here, and it was over our S region here was the triangular region with these vertices. We parametrized the triangle, and we got this, and we parametrized it over a right triangle here in the UV plane. Okay, so now we have to show in this video that the line integral around C, so C here would be the boundary of our triangular region here. So the line integral around F here should be 75. We need to show this in this video. So let's start doing that. So we have to first try and get the orientation correct. So here's our normal vector from last video. It's not clear now because I haven't drawn this triangle in 3 dimensions really, but you have to figure out where does the normal vector, is it sticking out of the triangle or sticking into it? And that could be tricky enough to figure out, so I'm going to show you a different way to do it that doesn't require you to figure out the normal vector. So let's talk about that. So to find the correct orientation around my boundary of S here, what I'm going to do is go around in a counterclockwise direction, like in Green's theorem, on my D region, and then map it over to the boundary over here. So these guys will map over to things over here, and it'll give me the correct orientation doing it this way, without having to use the normal vector over here. So let's parameterize these guys. Okay, let's do C1 tilde first. So I'm calling our parameterization of C1 tilde R1 tilde. There's going to be start point 0, 0 plus end point 1, 0 minus start point times t. So when you work this out, you get just t 0. And again, when you parameterize a line, it goes from 0 to 1. So that's parameterizing my C1 tilde guy. Let's do C2 tilde next. Let's call it R2 tilde. So I'll get this then. So it'll be my start point, which is 1, 0, plus my end point, which is 0, 1 minus start point times t. So working this out then, we get 1 minus t comma t. And lastly, let's do the parameterizer C3 tilde. So it's going to go from this guy down to here. So let's call it R3 tilde. So doing that will be our start point, which would be 0, 1 plus end point 0, 0 minus start point times t. So it ends up being 0, comma 1 minus t. Okay, so now let's map these over to parameterizations of my boundary over here. Okay, so I'm going to define my R1 of t to be R, which again R is this guy up here, parameterization of the surface. It's going to be composed with R1 tilde of t, and R1 tilde is t0, so it's going to be then R of t0. So that's my u then, and my v0. So put u equal to t up here, and put v equal to 0, and let's work it out. So doing that, so again, t in place of u up here, to be t there, and 0 in place of v, so it'd be minus t plus 1. Then do the same on those other ones, it'd be 4t plus 2, and then 5t here. So let's figure out where at time 0 where we're at in the time 1. So now when I put 0 in place of t here, here, and here, it'll become 1, 2, 0, which is my p0 point. And when I put 1 in place of t here, here, and here, it becomes 0, 6, 5. So it looks like it's going like this. I'm going to call that C1. Okay, now let's look at R2. So R2 is going to be basically R composed with R2 tilde of t. So let's do that right down here. So my R2 of t would be R composed with R2 tilde of t. R2 tilde is 1 minus t comma t. So therefore that's going to be your u and your v, and you're up here. So up here I'm going to put 1 minus t in place of u here, here, and here, and t in place of v here, here, and here. So let's do that over here. So doing that, I get this. So again, I'm putting 1 minus t in place of u up here, 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 and here, and putting t in place of v here and here. So I got this. So simplifying this, we get, so I get this then. And let's evaluate now at 0 and 1 to see where we're at on over here. So let's put in 0 for t and 1 for t. So putting 0 in place of t here, here, and here, we get 0.65, which is our P1. Then putting 1 in place of t here, here, and here, we'll get this guy, which will become 729, which is P2. So it looks like we're going this way. I'm going to call that C2. Okay, so I've called it C2. Now let's do our R3. So R3 is going to be R composed with R3 tilde of t. So let me do that. So my R3 will be R of R3 tilde of t, which will be R of 0, 1 minus t. So it'll be 0 in place of u, 1 minus t in place of v up here. So let's do that. So again, putting 0 in place of u up here, and then 1 minus t in place of v up here. I get this. Simplifying, you get this over here. So you can check, we're just looking at if you put 0 in place of t, you'd be at 7, 2, and 9. So you're starting here and going up this way. We'll be going this way. Let's call that C3. Okay, so let's summarize. So I can find the positive orientation of my S region by going counterclockwise around my D. I can always do that. In this case I did it because it wasn't clear which way the normal vector was sticking. Was it out of the triangle or into it? So this is the best way to figure out the positive orientation then for this guy. Okay, so let me erase some things and we'll keep going. So summarizing, we got our R1, or R2, and R3, which parameterizes the positive orientation of my C. So to find the integral around C, we're going to do around C1 plus around C2 plus around C3. Okay, and there's my F over here. Okay, so let's start doing the C1 guy first. So here's my integral over C1. So it's going to be integral 0 to 1 f of R1 of t dotted with R1 prime of t. So let's do R1 of prime of t up here. Well, it'll be derivative of this guy with respect to t would be negative 1, 4, 5. So let me write that up here. Okay, so here's my R1. So I'm using the ijk notation. So derivative of the first component would be negative 1, so it would be negative I. Derivative of the second component would be 4, so it would be 4j. Derivative of the third would be 5, so it would be 5k. Okay, this is going to be my x, y, and z. So I'm going to plug into my function over here. So in place of z, I'm going to write 5t here. In place of y, I'm going to write 4t plus 2. In place of x, I'll write 1 minus t squared, so forth. Let me write that here. So look at this. So again, z, so z is 5t, y is 4t plus 2, plus x squared, x is 1 minus t squared, j plus yk, y is 5t, y is 4t plus 2. Then we're dotting it with our r1 prime, which is negative I, 4j plus 5k. So let's do this dot product now. Let me write down here. So doing a dot product, so it'll be negative 1 times this guy, so it'll be negative 5t times this stuff, 4 times this, and 5 times this. Okay, so let's multiply this out and combine like terms. So multiplying it out, we get this. And now let's combine like terms. We get this, combine like terms, you can check. And then integrating, so it'll be negative 16 t cubed over 3, 2t squared over 2, 2's will cancel, and 14t. Okay, let's do that. So we'll get this, and then just putting 1 in, and then putting 0 in. I'll let you check when you plug those in and simplify, you get 29 over 3. Okay, so we did the integral over C1. So it's 29 over 3. So let's do now the 1 over C2. Okay, let's do the integral over C2 now. So here's my formula. So I need to compute R2 prime. So derivative of 7t would be 7. So it'd be 7i minus 4j plus 4k. So let me write that here. Okay, so I've written it up here. So now we're going to go f composed of R2. Now the 7t is my x, the negative 4t plus 6 is my y, and the 4t plus 5 is my z. So when I plug into this, I'll be making those substitutions. So let me make those substitutions and write it down here. So I'll get this. So again, it's going to be z, so 4t plus 5 times y, negative 4t plus 6, and plus x squared, x is 7t squared, plus y, negative 4t plus 6, okay, and here's my R2 prime. So it's going to be 7 times this, the I component here, negative 4 times this one, and 4 times this. So let's do that dot product. So after the dot product, we get this. So we just have to expand all this stuff out. I was going to give you the answer on this one, so I'll let you just pause the video and multiply this stuff out and combine like terms. This is what you should get. So you should end up getting that when you multiply it out and combine stuff. Okay, now let's integrate this. So it'll be negative 308t cubed over 3, 12t squared over 2, and 234t. So let's do that. So integrating, we get this. I know when you plug in one, let you check and simplify, you'll end up with 412 over 3. Okay, so we've done C2 now. One more to go. So let's do C3 next. So lastly, we'll do our integral over C3. So my R3 is over here. So we need to do the derivative of R3. So derivative of negative 7 minus 6t would be negative 6 there, 0, and minus 9 here. So let me write that over here. Okay, so I've written it up here. So now here's my f again. This time my x would be 7 minus 6t, my y would be 2, and my z would be negative 9 times t minus 1. So I'm going to plug into this and then dot it with this. So let me write it right here. So doing that, that's what I get. So again, my z is negative 9 t minus 1 times my y is 2 here. And then it will be plus x squared, x is 7 minus 6t squared, and then times, plus yk, y is 2, then dot it with our guy here. So let's do this dot product now. It'll be negative 6 times this guy, 0 times that, negative 9 times that. So let me write it here. So doing our dot product would be negative 6 times this guy. So that's negative 18 times minus 6, it'll be 108 times t minus 1. And 0 times that will be gone. That'll be negative 9 times 2, negative 18. Then let's multiply that 108 in there and combine stuff. So doing that, we get this then. So now we can integrate this. So it'll be 108 t squared over 2, so it'll be 54 t squared minus 126t. So look at this, and then you're going to put 1 in there and work it out. It ends up being negative 72. Since the other guys have thirds down here, let's write this as negative 216 over 3. Okay, so now let's add all the results together, and it should be the same answer we got from video 1. So in particular, it should be 75. So let's check out and make sure it's 75. Okay, so now a moment of truth. So the line integral over C will be the one equal to over C1, over C2, over C3. So over C1 we found was 29 over 3, over C2 we found was 412 over 3, and over C3 we just found was negative 216 over 3. So when you add those, it's 225 over 3, and you can check that reduces to 75. And that's the same answer as we got in the part 1 of the video. so the double integral. So let me just summarize. So hence we've shown then, so in part 1 we showed the double integral guy was 75, and we just showed this one 75 also. So that verifies Stokes' theorem. So we're done. We verified Stokes' theorem.